Greetings, my name is Aidan Stark and this is my Enme435 Homework 6 Face Tracker project. In this project, I was tasked with using a face detection algorithm to track a user's face and keep it centered on screen. The face detection function is performed utilizing an algorithm from OpenCV and is programmed in Python. I will now overview the process used to perform face detection. First, I pass the image from the web camera to the function cv2.dnn.blobFromImage. This function takes an image given and performs the necessary pre-processing of the image before giving the image to a neural network for interpretation. This pre-processing does two things: performs a mean color subtraction of the image, and it scales the color values after mean subtraction. Mean color subtraction means it will subtract the mean color of the image from every pixel in the image. Scaling involves scaling all of RGB values in the image by some factor. For my algorithm, a scaling factor of 1 was used, and the mean RGB color value given to the cv2.dnn.blobFromImage function was 104, 177, and 123, respectively. Before this image can be passed to a neural network, I have to specify the neural network model being utilized. This is done with the function cv2.dnn.readNet from cafe function, which will read in a file from the local directory. This will inform the deep neural network how to perform its analysis. This also requires having pre-trained a model to perform facial detection. With the model imported into the neural network, I then pass the processed image from cv2.dnn.blobFromImage to the neural network with the function net.setInput. Lastly, I acquire the output from the neural network with net.forward, which provides me with the data related to facial detection. This includes all faces that detected in the image, its percentage confidence that each detection is a face, and the points that constitute the bounding box around the face. At this point, I've acquired 4 points which indicate the 4 corners of the rectangle that closes the detected face. I also get the percentage confidence from the program that what is detected is a face. Utilizing these 4 points, I draw a bounding box around the user's face, as well as to write to the screen the percentage confidence. My first step was to determine what the total size of the window frame should be. Since the image from the web camera pans around the window screen to keep it centered, I had to ensure that as it pans around, it does not move off the window. If the face is located at any of the edges of the web camera, then the web camera image will be located entirely to the top, bottom, left, or right of the window frame center. Thus, I set the aspect ratio of the window as double that of the web camera. The window frame is set to black. If a face is detected, it will then overwrite these pixels with pixels from the web camera image. To determine where to put the web camera image in the window, I look at the coordinates of the face detected in the video. In the drawing shown here, you can see the key dimensions that I work with. Since the face will always be centered, the top left corner of the web camera image should be located a known distance from the top left corner of the face boundary box as given by the OpenCV face detection algorithm. I also know the location of the top left corner of the face with respect to the window frame, since it is displaced from the center of the window frame. In the X direction, it is displaced half the width of the face from the center of the window. In the Y direction, is displaced half the height of the face from the center of the window. Since the web camera image size is a constant, and I know where the top left corner of the web camera image should be located to keep the face centered, I know which pixels within the window should be replaced with the web camera image. One of the issues I encountered whilst working on this project was having the neural network to detect multiple faces from my singular face. This would confuse my program as it would not know which of the detected faces it was meant to follow. This caused the program to have random jumps where the web camera image would erratically shift on the window frame. To correct for this, I initially increased the percentage confidence requirement for face detection from 50% to 70%. While this did help, it did not wholly resolve the issue. I then took a second measure of analyzing each of the detections from the neural network, looking for the face with the highest percent confidence, and having the program only follow that face with the highest confidence. I will now demonstrate the functionality of my program. This has been my Enme435 Homework 6 Face Tracker project. My name is Aiden Stark, and thank you for watching.